MVS ESA represented another phase of this evolution by introducing another type of virtual storage structure called the data space, which could be used by programs to store large amounts of data. An important point to remember is that those virtual structures provided a means for programs to be able to exploit additional uses of memory, but they also required the availability of real memory to hold them. So as we indicated earlier, if we overcommitted our virtual storage use, then we could incur performance penalties as the system engaged in more paging activity. zOS then further expanded the architecture to include 64-bit addresses. So this provided expansion of the amount of real memory that could be installed, as well as providing larger virtual addresses that could be exploited to hold larger amounts of data in processor memory. In this way, the operating system environment was expanded to allow for larger and larger amounts of data to be held in memory, and the speeding up of applications that were dependent on high-volume data access and rapid response times. In this screen capture, we have another display that illustrates the concept of real and virtual memory by showing the real memory address in the left column, while in the next column it shows the virtual address it is associated with. In addition, the column labeled region indicates which part of the virtual storage divisions this particular address is associated with. For example, if we look at real address 0004000, we can see that it is mapped to the virtual address of 0002D000, which is part of the private storage used by the work called port map. In addition, there is a column called R, which indicates whether the page has been recently referenced. From this, we have seen that the introduction of virtual storage resolved several problems that were fundamental to real memory-based systems and how the architecture evolved to provide a uniform structure that would provide sufficient memory to run work, while simultaneously protecting operating system resources from being impacted by programming errors. In addition, by providing trimodal addressing, downward compatibility could be maintained while simultaneously providing a growth path for new applications and support for larger data reference requirements. Let's now move on to examine zOS task management.